Hi, I'm Matt Needham, and this is my lecture on duct systems. Now, when we talk about ducts, we're talking about the pipes that the air travels through in air conditioning and ventilation. So these pipes or ducts are usually large diameter, usually above 6 inches in diameter. And the big square pieces that come right off the supply are generally called plenums, and then we have individual ducts that tap off of that. And here at the beginning of the chapter of the Uniform Mechanical Code, chapter 6, it talks about how these ducts have to be made of and insulated with non-flammable materials, which makes sense, particularly in the supply. And there's a couple of exceptions. That's what you'll notice also about the code is somebody writes a law and then they write 5 or 6 exceptions. It can be a little complicated, but an exception would be return air, a duct or an air filter. And even think about some of the air filters have a cardboard frame around them, and the cardboard is flammable. So, but how can that be acceptable? Well, in the return air, or you haven't gotten near any electrical yet. You haven't gotten near the fan motor yet. You haven't gotten anywhere near the firebox, the heat exchanger, or anything that's very hot, or the fire, we could say. Everything, the filter and the return air are upstream of that, and that the air comes in, let's say, from the outside or the return air and goes through the duct and in through the filter, and then it's being pulled this way, and then the fan sucks it this way, and then pushes it generally through like a heat exchanger, which is the very hot part that the fire makes hot. So it's the airflow is always this way. So if you have an air filter and that cardboard is there, it's allowed to be acceptable. Also, as far as smoke detectors go with commercial systems and ductwork, if there's a tiny piece or whatever part in the smoke detector that may be flammable there, well, we don't want to have flammable things, but then we really want to ensure that we have the smoke detector. So, we're so much concerned with that if there is a small piece in the smoke detector that could be flammable, they'll look the other way. Now, pneumatic tubing, it says here, non-metallic pneumatic tubing in plenum shall be listed and labeled for use in plenums and shall not have a flame spread distance of more than 5 feet. So what is that? So pneumatic tubing is most of the buildings, large facilities, hospitals, big schools, high-rise buildings built in the United States from 1920 to maybe 1985 pretty much used pneumatic tubing instead of electrical wires to communicate, to control the air conditioning, because they weren't electrical. And a major concern when they started building high rises and big facilities is like, hey, electricity, can cause fires. And originally it wasn't plastic coating on the wires, it was cloth. Okay, so we had pneumatics, which gave us a little tiny tube, and you have these little tiny plastic tubes that look like long straws. And before that, it was just copper tubes. Okay, but probably since, I don't know, 1970, 65, we've had these plastic tubes that are run for pneumatics, and they're saying that sometimes you could run these through ductwork as a path because they're generally not flammable. And so it's controlling the air conditioning pneumatics with air signals traveling through little tubes instead of electricity. And that's a whole nother lecture. Okay. Let's talk about vibration isolators. A lot of times we have vibration isolators, and years ago they're connecting to ductwork, right? And I just mentioned canvas again here with the vibration isolators. like in the 1950s, 60s, and 70s, they actually were made of canvas, and then they tend to be made of rubber, a kind of rubber material, polyethylene, that was flexible. And that allowed, when you connected the ducts together, to give a little bit of leeway or play. So the alignment didn't have to be exactly perfect to the millimeter. And also, that there's movement with the air going through the ductwork, causes it to move a little bit. Um, and there's vibration, particularly with the air movement. And the metal ducts are actually excellent sound transmitters. And that people don't want to hear the sound of the loud motor and the air and all of that just humming down their ductwork into their occupied living space, office space, or what have you. So those rubber connectors cut down on that. Cut down on the vibration of the ductwork, these isolators, okay? And then they put a regulation in there that says they can't be more than 10 inches. Because then some people will be like, hey, you know, it's a lot easier to run rubber flexible down the whole thing, and I'll just say that it's a vibration eliminator instead of having solid metal duct, so they have to put a regulation that it can't be more than this, 10 inches. Okay. Here for under the floor or crawl space, shall not, air ducts installed under a floor or crawl space shall not be installed in accordance, shall be installed in accordance with the following. Shall not prevent access to an area of the crawl space where it is required to move under a duct to access an area in a crawl space. A vertical clearance of not less than 18 inches shall be provided. So that's not a lot of room. They're saying, like, especially think about a raised foundation house where you crawl out from under the house, right? You can't have ducts blocking someone's ability to get back to that house to repair a floor, do new plumbing, or whatever. But 18 inches isn't a whole lot, and I've been there under houses, you know, crawling on your belly. And now that I'm older and a little bigger, I've grown 6 inches. No, maybe it's my stomach. I'm kind of to the point where I'm really don't want to be crawling under houses anymore. I've done my share of that. Okay. Okay. Let's move on. Now, metal ducts installed off of the earth, let's say under a raised foundation, it has to be at least 4 inches up off the ground, okay? Which prevents critters from getting in there, insects maybe, a small crack, ants a little bit, but mainly it's for like water, for floods. Like you could have some torrential rainstorms, hurricanes in certain parts of the country, and you know, if water were to build up under a house, or if even a water line were to break under the house, right? You want that 4-inch clearance so you're not getting water in the duct, okay? And then here again, just a fundamental, we just go back and back and back to, this is probably the specific point that's mentioned the most in the code. The temperature of the air to be conveyed in duct shall not exceed 250 degrees Fahrenheit. So that's another kind of answer to a question. What's the maximum limit temperature for duct work for heating 250 degrees? And then you'll see that if you remember from another lecture, for electric heat, I think it's 200 degrees, and then under the floor, like if it's going under a house, like a duct, like we're talking now, if it's the ductwork is going underneath the floor to transmit the supply air, it's again 200 degrees. But generally, the maximum for everything is 250. That's a very old law, an old rule, and most manufacturers don't get near that. Again, they put their limit controls maybe closer to 160, something like that. Okay, let's move on. If a metal duct were installed in or under concrete slab, it has to be at least 2 inches of concrete supporting it. So you can't have a vehicle or a very heavy load that comes across a ½ inch of concrete and cracks it and then compromises the duct and et cetera, et cetera. Okay. Let's move on here. Insulating materials installed inside ducts shall have a mold, humidity, and erosion resistant surface that meets the requirements referenced in standard UL Underwriter Laboratories 181. And that 181 is, again, always about like ducts, duct sealing, things of this nature. I'll make the point, duct tape. There's 1,000 different duct tapes out there with mustaches on them and pink and turquoise and whatever you want. But the only one that's actually approved to seal ducts out of those 1,000 is one that's stamped UL 181. It's usually UL 181B, and that means you can seal up a duct with that. The others are more just like hobby stuff, or if you need it for any reason. Duct tape, there used to be a book, 1,001 Uses of Duct Tape, and it's a very handy thing just to have around, no doubt. But we don't want to have the insulation, here's the point, that can have mold and all that. Now, the insulation for ductwork isn't always around the outside. If you ask a sheet metal shop, if you're installing an air conditioning system for a plenum, actually you can order it where the insulation is on the inside of the duct sometimes, okay? And how do we rate insulation of any kind, whether it's in your attic, blown-in insulation, or for ductwork, or inside a wall, or inside a refrigerator wall, or whatever? It's the R value, the resistance to heat flow. The higher the R value, the slower heat travels through it. Okay? So, and you may hear this like, what do you have in your attic? Is it, an R15? Is it an R30? And R30 is better than R15 or whatever. And then there's these spray foam installations and things of this nature now where they claim to be R50, and that's a really good, and I'm a big fan of insulation as a way of saving energy. Energy management with the computers and everything and all the sensors, and I've worked with that. It's sexy, but it can fail. And I think first you put your money into good insulation, which is going to last, whether that's in attics or walls or sealing up cracks or better windows or whatever. That's going to last a lot longer without anything technically going wrong. Okay. Access and identification. Fire and smoke dampers shall be provided with approved means of access large enough to allow inspection and maintenance of the damper and its operating parts. Okay, so a lot of times it's tricky if you're in an attic or something. Sometimes it is hard to get to certain dampers and fire and smoke controls. So they're saying you have to have access to get to it. And I haven't always seen great access in some of these attics. It's almost like it's a very dangerous circus act to get to work on some of these things. Okay. All right, let's move on here to access shall be through. Now, to get to like ductwork under a house, under a floor, you got to have 24 by 24 inches is the code now. Like crawling under a house, you've got to have an opening where you can get under there, maybe bring new ductwork with you, supplies, so that's the standard there. And it's also talking about maybe if you had a trap door to get under, that has to be 24 by 24 inches. And then I gave you a preview about this temperature limit. A furnace supplying warm air to such space shall be equipped with an approved limit control that will limit the outlet temperature to 200 degrees. So, and that's a lot of times in older homes that don't have cooling, it'll be a downdraft, or we have upflow furnaces where the air comes in the bottom, heats up, goes out the top, generally through the attics, and then comes down. Then we have downflow where maybe you're getting the air from above and then it blows it up through these floor registers. And in a lot of other parts of the country that don't have cooling, they have a lot of floor registers that just come right out of the floor, and then the warm air comes out, and the warm air is lighter, and it kind of rises up to the top of the room. Yes, with the fan, but also just with that natural convection that the warm air is lighter, and it comes off the floor, and it rises up, and it kind of very nicely heats the whole room evenly and gives you a beautiful airflow into the room. And a lot of times in older buildings, you'll have a basement or in a garage or something underneath, and then the warm air is blown up out of a floor register. And then it talks here about that. It says, floor registers shall be designed for easy removal in order to give access for cleaning the receptacles. Generally, those floor registers, those vents are just sitting on the floor. And then you can pick them up and vacuum and clean out, which is a good idea. The problem with floor registers is when you tell your rebellious 14-year-olds to sweep the floor and they start sweeping, they might realize that they don't have to lean down with the dustpan. If they just sweep all the dust into the floor register, it magically vanishes. Not good. Not good at all. Okay. All right, and with that little joke, I guess we'll conclude this somewhat shorter lecture on duct systems.